1 e to minus j 3 omega. Right? How about u? You have exactly the same thing, but you're changing it from 0 to 4, 6. So you change the index. You're scaling the index. You scaling the index. All it's doing here is scaling this factor from 1 to 2. Okay? So it's very easy to generalize this, right? If I have 3, what does it look like? J of 3 omega. Okay, so this is L equal to 2, right? L equal to 3. What's the index look like? 0, 3, 6, 9. And 0 in between. Right? So what happens? The index scale. So the index scale, the exponent of the Fourier transform scale accordingly. Okay, so this is L. I have U equal to X e to the j L omega. I'm staying with 2 so that I can draw easier and so on and so forth. Any question? And what is Y e to the j omega equal to? It's a product, right? This is linear time invariant system. So Y equal to H e to the j omega time X. Scale. Okay? Let's see what happens in the 15 domain. Okay? So let's take an example. Suppose X e to the j omega equal to, let's say, a signal like this. Okay? Let's take an example. Suppose this is my spectrum of my signal X, a low pass spectrum right there. An example. Okay? How do I plot the spectrum for U? How does U of E j omega equal to? Good. 5 over 2. Okay. So here is, you can look at the duality, right? In time domain, this operation stretch to support. What happens in frequency domain? We compress, okay? And do the opposite way, okay? So here we take the support from 0 to 3, stretch it to 0 to 6. Frequency domain, we go by half, right? So at pi over 2, pi. So this support right here will map into minus pi over 2 to pi over 2. Give still exact value. Are we done? Not yet. Why? What happened at pi? You see, this is periodic. So 2 pi will map to pi. So this dotted line here is right there. And so on. Okay, so if I look at any 2 pi period, so here's pi, 3 pi over 2, here's 2 pi, I have, so if you look at, from minus pi over 2 to 3 pi over 2, I have the original spectrum and an image, right? This is called image. Exactly the same, but shift by pi. Okay? Now, what happens when you have 3 here? What happens when L equals to 3? So here is L equals to 3 for the same input. Okay, here's L equals to 2, L equals to 3. So I'm going to do exactly the same thing. Instead of upstanding by 2, upstanding by 3. Okay, what does it look like? 3 omega. Right? We have X of e to the j 3 omega. So here is 0. Okay? So what is this support will map to? What is minus pi to pi map to? 2 pi over 3 to 2 pi over 3. I mean pi by 3 to pi by 3. Right? Scale by by 3. Yeah, minus pi by 3 to pi by 3. Pi. Like that. Okay? What happened next? What happened over here? An image, right? We have this copy. Continue, right? So it could be like this, an image there, and in the other side, over here, another image. Okay? So it could be like this. So when L equals 3, I have 2 images. I have the original spectrum compressed, a factor of 3, and I have 2 images. Okay, this is the pair of 2 pi, minus pi to pi. I have the original spectrum compressed in, and I have 2 additional images. Now for the 2, I have 1 original spectrum and 1 image. When this is L equal to arbitrary number, what happens? I have the original spectrum compressed by a factor of L. And I have how many images? L minus 1. Is that clear? Yeah. Okay, good. Any question? So what we have done so far is we see that how this upsampling happens in the frequency domain. Okay? Any question before I erase this? So the next step is we know what happened to U. Right? For given X, I know how to draw U. I want to now draw Y. Okay, so I'm going to erase some of this, and we will draw Y. So let's do that. Here. Okay, so X. So let me again review. X upsampling by 2. We have that. Okay. Now I'm going to talk about H. Right. And the example we have 1/2, 1/1/2. You can show that this is basically a low-pass filter, right? So let's assume you have an ideal filter here. An ideal low-pass filter, 5/2 to 5/2. Okay? What does the output look like for this filter? I'm going to draw the frequency domain of the output, y of e to the j omega. So how do I draw that? So I'm taking U, right? Convert with that filter. In frequency domain, what do we do? We multiply, right? We take this one, we multiply frequency by frequency to get this. And because this is exactly 0 for ideal filters, what do I know about from pi with 2 to pi? 0. Right? Because multiplication of 0 is 0. I have 0 here and 0 here. Any questions? And because this ideal filter is 1, right, in the passband, I'm going to preserve that compressed spectrum. So I'm going to have okay, this is Y. Now, suppose I don't want to do that. I can't do this. So what happens when I take this U? I'm going to a different filter. So how do I do this? Erase that. So here is a case where H is a low pass filter. Okay. So we'll take U here. Different color, going through, let's say H prime, going to Y prime.